Good day, guys. Welcome to my YouTube channel. In this video, I want to explain argument of complex number. And the objective of the video will be to define the argument of a complex number and to calculate the argument of a complex number using Argand diagram. So the keywords that we are going to be explaining on this lesson are Argand diagram, arguments, quadrants, angle. Argand diagram, arguments, quadrants, and angle. So we take them one by one. The first one is Argand diagram. Argand diagram, as you can see, is a prototype of a Cartesian plane. The only difference between Argand diagram and Cartesian plane of y and x axis is that the y-axis of Cartesian plane is replaced by the imaginary number of a complex number, imaginary part of a complex number, while the x-axis is replaced by the real part of imaginary number. So we use imaginary part and real part for our vertical and horizontal axis respectively. Now, the meeting point of the imaginary part and the real part is the origin. Now, the right-hand side of the real part, the right-hand side of the origin of the real part is positive. This is the positive real part. Positive 1, positive 2, positive 3, and so on. And to the left, we have negative real part. And up the origin, we have positive imaginary parts. And down the origin, we have negative imaginary parts. So this diagram is called the Argand diagram of imaginary line. So the second keyword is argument. What is argument? Arguments, the argument of a complex number z, that is argz. Argz, you write it as argz. So if you're asked to find argz, it means find the argument of complex number z. So is the angle theta between the positive real axis and the line joining the point to the origin. The angle between positive real axis. Positive, not like I show here, this is real axis, this is positive real axis. It means we measure the argument of complex number from positive real axis. Take note, only from positive real axis. So the reference is made to the positive real axis. Okay, now the next thing we talk about is quadrants. Now, what is quadrant? Now, if you have the Argand diagram with imaginary and the real axis, you can see that we have 4 parts in the plane. The first part or a section is called first quadrant. You don't call it first section. You don't call it first part. Say first quadrant, second quadrant, third quadrant, and fourth quadrant. Don't forget the reason why this is first. This is the positive real axis. So we start from positive real axis. We go anti-clockwise. First quadrant, then we move second quadrant, then we move third quadrant, then we go fourth quadrant. So there are 4 quadrants there. So each section of the 4 segments or 4 parts of the Argand diagram is called a quadrant. A quadrant. And we are going to need it as we go on in the class today. Okay. Now, the next thing we need to talk about in this class is I think we need to talk about angle. Yes, we need to talk about angles. We need to talk about angles. What are angles? What are angles? So that is another thing we need to talk about. So let me quickly talk about angles. Okay, angles. Okay, when we talk about angles, there are two types of angles. We have angle theta, we have angle alpha that we'll be talking about in this class. The first angle theta is the argument of z, or you can say is our axis. Then alpha is the acute angle that will help us to determine the value of argument where necessary. Where necessary. For example, if you want to determine the argument when the point is on the second quadrant or on the third quadrant, we need alpha. So when we get there, we're going to learn more of angle theta, which is the argument. But anytime you have to find the argument of a complex number, you know that axis is the theta degree, or is the theta. Is the theta. Is that clear? Okay. Now we are going to take 4 examples only in this class. Just 4 examples in this class. Just 4 examples in this class. Okay. Now, example number one. Example number one. This question says example. Example. I have the question we say find the arguments. Find the arguments of the following complex number of the following complex numbers. Okay, okay. The first one is a z1. The first complex number is z1, and the number there is equals to 2 plus 3i. The second one is z2, and z2 is given as minus 5 plus 3i. The third one is z3, and z3 is minus 3 minus 2i. And the last example we are going to do is z4, for z4. And this is given as 3 minus 2i. So we are going to solve them one by one using Argand diagram. We are going to solve them one by one using Argand diagram. So let me start from the first one. So from the first one, this is our Argand diagram. Okay. This is the imaginary parts. This is the real parts. This is the origin. As you can see from this question, the real part is 2, meaning we are going to have 2, 1, 2 on the real axis. And the imaginary part is 3, 1, 2, 3 on the imaginary axis. So the meeting point of 3 and 2 will be here. So we have a line drawn to the origin. So from here, we can have the vertical and the horizontal. This is the vertical dimension and the horizontal dimension of the points. So the vertical dimension, is going to give us 3. The horizontal dimension is 2. And we know this is the angle between the line that joins the point to the origin and the positive real axis. So it is 2, 2, and 3. So this is a right angle triangle. And this is the angle theta, which is the which is the argument of the z1. Okay. So to find this, we can see that we have opposite of the angle theta and the adjacent. So it means the most appropriate ratio is tan theta. Tan theta equals to 3/2. Don't forget, take absolute value because we are finding angle. Okay. So we can now say theta equals to tan inverse or arctan 3 over 2. So what is arctan 3 over 2? Theta equals to arctan 3 over 2. Let me take my calculator and get that. Okay. Okay, which is equal to 0.9828 radian. 9828. That's I give my solution in radian. Radian. So that is the answer for the first one. So we measure from here to here because we always measure from the positive real axis. Okay, that is example number 1. So let's take the second one, number 2. Let's leave that one aside and take the second one, number 2. We have Z2, let me use this, Z2 equals to minus 5 plus 3i. So let's take our Argand diagram for Z2. Argand diagram for Z2. Okay, let me cut this one small. Okay, we have Argand diagram for Z2 like this. This is the imaginary part and this is the real part. Okay, this is the real part. This is the imaginary part. Okay, now from what we see here, the real part is -5, the imaginary part is +3. So 1, 2, 3, 4, 5, 1, 2, 3. So meeting points will be somewhere around this place. Sorry, somewhere around. Let me take it off. So we have 1, 2, 3, 4, 5, 1, 2, 3. So meeting point will be somewhere around here or here, yeah, or here. So from there you can draw your line straight down to this place. So, and this is the vertical and the horizontal dimension. Vertical dimension, horizontal dimension. Vertical dimension is 3, horizontal dimension is -5. This is the angle, this is the right angle triangle. Now, what is going to be the theta? I mean the argument. Is going to start from the real, positive real axis. So you want to measure like this, positive real axis. So this is our angle theta 2. Now, how do we determine angle theta 2? Now, it is very important I let you know that the argument of real of a complex number axis is the angle that is defined by inequality minus pi less than theta less than or equals to pi. That is between minus pi and pi. So, and from here to here is pi. From here to here is pi. Okay, that is 180 degree. All right. So if you want to find angle theta, you need to first find the acute angle here. So that's why we label this acute angle alpha. So if I find angle alpha using this right angle, the acute angle alpha using this right angle triangle, then I will subtract alpha from pi, from 180. That is 180, which is pi minus alpha. So theta 2, I can say that theta 2 equals to pi minus alpha. Equals to pi minus alpha. No, pi, since pi equals to 180 degrees. So no, this is 180 degree to this place. So pi minus alpha. So let's determine the value of pi. Okay, so we know that. Now let's examine the value of alpha. So alpha is an acute angle with opposite 3 and adjacent 5. So we can say tan alpha equals to 3 over minus 5, take absolute value, with alpha equals to tan inverse 3 over 5. So, which is going to give us tan inverse 3 over 5. Tan inverse 3 over 5. Let me use my calculator to do that quickly. Let me use my calculator, which is 0.5404. 0.5404. That's our alpha. So if alpha is 0.5404 rad, then theta, according to what I have here, theta 2 is pi minus alpha. Is pi minus 0.5404. So theta 2 equals to, so what is going to be our theta 2? So use my calculator. Theta 2 is 2.6011. 2.6011 rad. That is theta 2. I think you remember what I did. I measured the argument from positive real axis to this place. So that's our theta 2. And for us to determine the size of this angle, we need to know the size of this acute angle here. So how do we know the size of this acute angle here? We take tan of alpha and it gives us 0.5404 radian. So we subtract this from pi, that is 180 degree radian. So, and we got 2.6011 rad. That is the second question. Now, the third one, let's go to the third question now. Let's go to the third question. So Z3 is Z3 is minus 3 minus 2. Okay, so Z3 equals to minus 3 minus 2i. Minus 3 minus 2i. We want to find Z, that is argument of this. So the first thing we need to do is to have our Argand diagram. Argand diagram. This is Y. Oh, sorry, I said Y. Oh, what do we call that one? We call it imaginary. Thank you, imaginary. And this is the real. This is the real axis. Imaginary axis and the real axis. So our imaginary axis here, as you can see, is negative. Imaginary axis is negative to 1, 2. Real axis negative 2, not positive. Thank you. 1, 2. Real axis negative 3. 1, 2, 3. So they are going to meet somewhere around here. So we have a line like this. So this will be the vertical components, and this is the horizontal component, which is minus 3 and minus 2. So we want to measure this angle. If you want to measure this angle, you measure, don't forget, we always measure our argument from the real, and it's between negative pi and positive pi. So you cannot go like this. If you go like this, it's more than pi. So you have to go in the opposite direction. This going like this is positive pi. This is positive pi. But if you move like this is negative pi. I hope that is clear now. Moving like this, positive pi and negative pi. I think that is very clear, okay? Now, so if you want to, here we can't move in this direction. So we have to go in this direction. So our argument will be in this direction. So this argument, and this is going to be theta 3. So how do we find theta 3? We need to first of all recognize that this is right angle triangle with an acute angle alpha here. So for us to be able to find theta 3, we need to say, no, don't forget, I told you that if you move from this positive real axis on this opposite direction here, you are moving negative alpha. So definitely, if you want to find angle theta 3 will be negative alpha minus negative pi minus alpha, because you are moving in negative direction. Negative pi minus alpha. Negative pi minus alpha. If you are moving in this direction, when we move here, we say positive pi minus alpha. So it's negative pi minus alpha. So in that case, what is pi? So the first thing we need to do is to calculate our alpha. Let's find alpha. This is the opposite. This is the adjacent. So tan alpha equals to opposite minus 2 over minus 3. So we have to take absolute value. Is alpha equals to tan inverse 2 over 3. Then alpha is tan inverse 2 over 3 is going to give us 0.5880. That is tan inverse of 2 over 3. Tan inverse of 2 over 3. Now, when we know tan inverse of 2 over 3, we want to find theta 3. I said theta 3 is negative pi minus theta. So it means theta 3 is going to be negative pi minus 0.5880. Okay, so which is negative. What do we have? Pi minus 0. Pi, let me use my calculator. Pi, that is minus 2.554 rad. That is the correct answer. That's the correct answer for theta 3. Okay, and lastly, let's go to the last question. Theta, that is Z4. Z4. That is 2, 3, Z4 is 3 minus 2i. 3 minus 2i, Z4, okay? Z4 equals to 3 minus 2i. Let's see which quadrant this will fall into. Let's see which quadrant. Okay, this is our Argand diagram. We have imaginary, and then we have real axis, okay? So, and 3 real, that is positive, 1, 2, 3. Negative, imaginary, 1, 2. Definitely, they are going to meet somewhere here, like this. Good. Like this. Good. So in that case, we have the vertical dimension and the horizontal dimension. Horizontal dimension is 3. This is minus 2. Then we are going to have, since we are moving from this place and we move in this direction like this, so we are going to move like this from this direction. So this is our theta. There's no need for alpha here. This is our theta. We just move our theta. So it means our theta 4 is going to be negative direction. We are moving in negative direction. It's going to give us a negative value. It's going to give us a negative value because we are moving in negative. If we are not moving like this, we are not moving up like this. This is pi. If we are moving like this, it's negative pi. Okay. So since we are not moving in the positive direction, we are moving in negative direction. So our theta 4 now will be minus tan inverse of 2 over 3 minus tan inverse 2 over 3, which is going to be minus tan, what is tan inverse 2 over 3? 0.5880 rad. That is the answer for this question. So I believe you enjoy the video very well. So I want you to go on and subscribe, like my video so that you can enjoy more other videos that I will be uploading in this channel. Thank you for attending this class. Bye.